Okay, let's talk critical points. Critical points, critical values, that's another name that you might hear. Okay, so I'll write that down, critical values. We've got a fancy definition here. It says an interior point of the domain of a function f, where f prime is 0 or undefined, is a critical point of f. Okay, real simple. Look at the graph. Wherever the derivative is 0, critical point. Wherever the derivative is undefined, critical point. Okay, so there's different things. Obviously checking where it's 0 is not terribly difficult. Maybe the undefined part is a little difficult for you, but consider you may have like an asymptote, discontinuity of a function because it jumps or something like that. That's where you have a problem. Okay, so what we're going to do is we're going to take a look at number 4 here, and it's real simple. We're just going to find the derivative and then set the derivative equal to 0. And wherever that happens, critical point. Now I know this one is not undefined anywhere because it's a polynomial function, but number 5, it's got a point where it's undefined. So we'll talk about that one too. So here's the derivative. Derivative of x cubed is 3x squared. Derivative of negative 12x is negative 12. Derivative of 4 is 0. So yeah, that's about it. All right, 3x squared minus 12. I'm going to factor out 3 from this, and I'm going to get x squared minus 4. And this right here is what I call dots. What is dots? A difference of 2 squares. So I'm going to set that equal to 0, but then of course it's a difference of 2 squares, so I factor it very quickly and I get something like this. Okay, so it's very easy now. We set each of these equal to 0 and we can say, well, x equals negative 2 and x equals positive 2. So the critical points here for this problem number 4, critical points at x equal negative 2 and 2. There we go. All right. Now let's take a look at this next problem, number 5, and let me move it up a little bit. This one, derivative, maybe not as fun. We have to use the quotient rule, high, low. So let's write that out. Okay. High, the function on the top, is 4x. Low, the function on the bottom, x minus 6. D high, the derivative of the top, is 4. D low, the derivative of the bottom, 1. All right, but it's not that bad to find f prime of x. What does that look like? Low d high. So that's x minus 6 times 4, or 4 times x minus 6, minus high d low, which is just 4x times 1, so 4x. Now this is going to require, of course, some distribution there, but then it's all divided by low, which is the bottom, the denominator, squared. Okay, so then we get 4x minus 24 minus 4x, all divided by x minus 6 squared. So when we combine our like terms, 4x and minus 4x, we get negative 24 over x minus 6 squared. Okay, now there's no place that this would equal 0. Okay, there's no place where it would equal 0 because the numerator would have to equal 0. But we just look here at the denominator. Where does the denominator equal 0? All right, that's at x minus 6 equals 0. So x equals 6. All right, that's the point where we have an asymptote. All right, so what we can say is that I can make this statement: f prime of x is not equal to 0, but f prime of x is undefined, and this is just my note to you, at x equals 6. So we can say we have a critical point at the value x equals 6. And that is what we will jot down for this problem. Okay, so remember, important part here is that a critical point is wherever the derivative equals 0 or wherever the derivative happens to be undefined. So really easy concept here. I hope this video was helpful, and remember, like and subscribe.